Hello and welcome. In today's video, we are going to be going over topic 4.2, the mean value theorem. So, to start out, we want to find where the following functions have critical points. As always, this is just review. And if you want, you can try and skip later in the video to get to the mean value theorem stuff. So we get dy dx is equal to 1 over x. Now, if you recall from yesterday's video, or 4.1, rather, we are looking for where x, or the function, or the derivative of the function, is undefined. So at this point, we can clearly see x equals 0 is going to be a critical point. However, is it actually going to be one? We'll find out how to tell that in the next video. For this next function, we need to start out by taking the derivative. And because this is a polynomial, it's continuous for all real numbers, which is important. So dy dx is going to be equal to x squared minus 3x minus 4. Now what we're going to do to find the zeros of this, or we're going to factor this function, so we get dy dx is equal to x minus 4, and what looks to be x plus 1, pardon me. Then we need to set these equal to 0. So this gives us two circumstances. We either get x is equal to 4 or x is equal to -1 for critical points. So, just before we get to the mean value theorem, we need to know Rolle's theorem, which states let f be a function of the following, or let f be a function that satisfies the following conditions. F is continuous on the closed interval from a to b. F is differentiable on the open interval from a to b. And f of a is equal to f of b. Then there is a value c in the interval a to b such that f prime of c is equal to 0. So using Rolle's theorem, explain why there must be a value c in the closed interval from -1 to 1 of f of x is equal to x squared. So to start off, we know this is a polynomial. So Rolle's theorem, so the function is continuous. Function is continuous. Is continuous from a to b, and for justification of that, we're going to say because f is a polynomial. Alright, I'm going to close that for right now. Alright, then the next condition that we have to see before we can, or the next condition we have to make sure it satisfies is it's differentiable, which is also true because it's a polynomial. The function is differentiable and I should specify -1 to 1 on the open interval -1 to 1, because, again, it's a polynomial. Alright. The final condition that we need to make sure we know is that f of a is equal to b. So, f of 1, or f of -1, is going to be equal to f of 1, because f is a even function, so it must be equal to 1. So, because of Rolle's theorem, there must be a value c such that f prime of c is equal to 0. And just to kind of show you why that is, what this really is stating here is that f of b minus f of a all over b minus a must be equal to 0. Well, if we know b and a are equal, so this becomes 1 minus 1 over b minus a, so we get 0 over 0, which is true for the Rolle's theorem. Hope that it gives you a bit more insight there. Similarly, we have the mean value theorem, which this is a very big theorem in calculus as it's used to prove the fundamental theorem of calculus, which sounds very important, especially with the fact it has the name of calculus in it. It's in the books like the fundamental theorem of algebra and that kind of stuff. So, the mean value theorem states, let f be a function that satisfies the following. F is continuous on the closed interval from a to b. F is differentiable on the open interval from a to b. So these two portions of this theorem are the exact same as Rolle's theorem. Rolle's theorem. All right. But this third one, what comes after it, though, is a bit different because we're not having a third line here. Instead, we're stopping and we're saying, then there must be a number c in, I suppose that was supposed to be an n, not an is, a to b, such that f prime of c is equal to f of b minus f of a all over b minus a. So for the following functions, verify the mean value function can be used and find all numbers c that satisfy the mean value theorem. Well, before I do that, I actually just want to do a bit more explanation. So what this really, the mean value theorem supposes, is there must be a value of the derivative where it is equal to the average rate of change of a function over the interval. And that's really just the entirety of the mean value theorem for you. So for the following functions, we want to verify the mean value theorem can be used and find all numbers c that satisfy the mean value theorem. So for this first one, let's think for just a moment, and I'm not going to write this one out. Is it continuous on the closed interval from 0 to 2? Yes, it is, because it's a polynomial. All right. Is f differentiable on the open interval from a to b? Yes, it is, because f is a polynomial. All right. So it satisfies the two conditions. So there must be a value c. So there must be a value f prime of c that is equal to, let's see, so that's going to be 2 squared, that's 4, that's going to be 8, minus 6, so 2 plus 1 is 3, minus 1, all over 2 minus 0, so we get an answer of 2. So there must be a value on the interval where f prime of c is equal to 2. How we solve for that is we need to take the derivative of this. So we get f prime of x is equal to 4x minus 3. And now we just need to solve for when that is equal to 2. So we get an answer of 4x is equal to 5, or x is equal to 5/4. And that's whenever the slope of the tangent line is going to be the same as the slope of the secant line over the interval. So let's think about this again. This is a polynomial, so it is differentiable and continuous for all real numbers. So then there must be a number c. So there must be an f prime of c such that from -2, or let's see, from 2, which in this case is going to be 8 minus 6, so 2 plus 2, which is 4, minus the value at -2, which is -8, plus 6, so that will be -2 plus 2, so 0, all over 2 plus 2. So we get 4 over 4, or f prime must be equal to 1 at some point in the interval. So f prime of x is equal to 3x squared minus 3x plus, 3. So what we're going to do is we're going to say f prime of x is going to be 3 times by x squared minus 1. We're then going to expand this out to find all the zeros, or factor this. And we can see, I did not want to do that just yet. Sorry, we're going to reset. Now what we're going to do is we're going to plug in 1 for the value here and solve it. So we get 3x squared minus 3 is equal to 1. We get 3x squared is equal to 1. It's not equal to 1, is equal to 4. Then we're going to divide both sides by 3, so we get 4/3 is equal to x squared. Then we're going to take the square root of both sides, so we get 2 over the square root of 3, plus or minus for our answers. And now just thinking about this, this is going to be a number that's going to be within the interval, because 2 divided by square root of 3 is going to be something a bit smaller than 2, and since we're going from -2 to 2, the positive and negative variants of this are not going to affect that. So these are just a few closing notes I have. If f prime of x is equal to 0 for all x in the interval from a to b, then f is a constant on a to b, and that's just shown by the fact of f prime of 0, and we can show this using the mean value theorem, where f prime of c is equal to b minus a, f of b minus f of a, all over b minus a. We're then going to multiply this over, so we get f prime of c times by b minus a is equal to f of b minus f of a. So then we get 0 is equal to f of b minus f of a. So what this really supposes is that these two values of f of x are the same for all values in the interval, as shown. As whenever you subtract the two, they're always equal to 0. And then if f prime of x is equal to g of x for all x in the interval from a to b, then f minus g is continuous on a to b. That is, f of x is equal to g of x plus c. So we are going to find a new function here as f, capital F of x. That is going to be equal to f of x minus g of x. Well, we're now going to take the derivative of this function with respect to x, and we get f prime of x is equal to f prime of x minus g prime of x. However, we know f prime of x and g of x are the same. So f prime of x is equal to 0. And because of this, because we know that f prime of x is equal to 0 for all x on an interval, which is true down here, what's it called? F minus g of x must be a constant. So as thus, that means that they are the same function, just shifted up or down. Well, I hope you all have enjoyed this video and found it informative. And have a great rest of your day.